my team, which is the Civil Infrastructure Research Cluster at University of Liverpool, where we are focusing on the development of a new low-carbon material. In particular, as you correctly pointed out, looking at low-carbon concrete, I would call it sustainable concrete as a general family, and I'm going to in detail in a minute, and also low carbon mortar. What we are doing in terms of concrete, and the reason for focusing on concrete is that it's still the mostly widely used for construction, and is also one of the material that has the highest carbon content in terms of embodied carbon, is that we are focusing on material that can replace the ordinary Portland cement, so OPC, typically named, with additional binders. And by additional binders, I mean GGBS, PFA, and more importantly, with working with one of my PhD, we are now also combining the replacement of such binder with self-healing agent, which means that we are now also exploring the possibility to eliminate one of the most dangerous effects for using concrete, which is the formation of crack. Now, crack itself may not be dangerous, but typically, I would say, in most of the structural applications for structures and infrastructure of concrete, we will see it used with reinforced bars, reinforcement steel, which is typically a very weak element if it is attacked by oxygen and it is exposed to harsh environment. Now, concrete has also the duty, and I would say the property, to protect as a shell the steel reinforcement bar. Now, if we create a shell that is highly impermeable, so it is not penetrable by any attack, then we can protect steel. That's where our research is focusing on. We are creating this very solid shell, which is made of self-healing concrete, which will not experience cracks, or at least we can avoid the presence of crack, so that the embedded steel will be protected. And this is very important, both for new and for existing infrastructure. New infrastructure, because this will then allow them to stand for more years without maintenance or reducing maintenance. But at the same time, we are also deploying technologies such that the new concrete can be sprayed on as a cover, as a coating on existing walls, on existing infrastructure, to make them more, to protect them and to make them by one of my PhD that now is getting close to the end. And the use of lime, which is going to replace typical cementous mortar, was very interesting, particularly for historical building. Now, there are a number of technical reasons why we'd like to replace mortar with lime. First of all, because lime is low carbon when compared in terms of carbon contents, embodied carbon, with respect to cementous material. But more importantly, there is the issue of compatibility, which is very important with respect to bricks. This is a crucial issue when it comes to historical building, because we don't want to, even for retrofitting, we don't want to endanger, we don't want to damage existing bricks. And more importantly, we also want to have high performance in terms of buildings. And what do I mean by high performance? We want to create the right environment without humidity, reducing the capillarity, so that we can't see a lot of humidity passing through walls. So we also want to ensure that buildings can be more comfortable, but at the same time, if we have, for example, walls with painting, they can be protected. That's very, very important when it comes to historical building. Now, this is a very sort of active research, and in terms of current project, we are extending this a little bit beyond what I've just mentioned. And for example, we are looking at multifunctional materials, where we are including, for example, additional performance for concrete. At the moment, we are preparing a proposal for self-sensing concrete, which means that we are focusing on a concrete that can tell us when it's not feeling well, if we can say like that, i.e. we can detect the illness or even the let's say some problem or defect that may appear in concrete because of exposure to humidity, harsh environment, extreme effect induced by climate change, for example, erosion, carbonation, and so on. Also heavy rain for permeability. And this is becoming very active research, as we are also working closely with other colleagues. We are partnering with other colleagues from other universities in the UK and across the globe in identifying sensors that can be multi-physics sensors that can be installed in particularly in new structures where this is a procedure very easy to implement, where sensors, for example, based on graphene, can sense the humidity, the change of pH, which are all the different type of condition into which concrete and the embedded steel reinforcement are working, so that again we can deploy proactive maintenance. Hence, we can make our infrastructure, next generation infrastructure, more resilient. Just to close on this, in terms of climate change, we are also investing a lot in terms of testing. So our approach, our unique approach, is based on design by testing, which we believe is very important when you deal with new materials, as code of practice may not be relevant, may not be present. Hence, because they are relevant for designers, we can then provide engineering evidence through design by testing that the property, that the mechanical strength, but also, how to say, the environmental properties that are very important are those that can be achieved with this material. And just to going to the last line, we are also looking at how to combine bio-inspired fibers, for example, hemp, for example, jute, cotton, recycled cotton. So also within the circular economy can help and can eliminate typical low performance of concrete, which we all know and we are all aware, which is low tensile strength. So fibers can distribute the cracks, can help to enhance the performance, can help to reduce to enhance the let's say the performance by reducing the maintenance, but more importantly to protect, as I said at the beginning, the embodied steel reinforcement. Thanks also for this type of question, which again really highlights the way we approach research in my team, as we work at the interface between academia and industry. And we believe that this is the knowledge transfer where we are very, that is something that really drives, is a very important driver for our research, is something that we really work actively towards, working with SME in the Liverpool City region, but also globally. We are engaged with global consultant, but also with other company that wants to bring to the next stage what they are investing on. For example, in terms of monitoring, we are, for example, working with a company that now is considering the application of multi-physics sensors for active structural health monitoring in offshore platform and also in nuclear industry. And this is something very important, because really the new frontier of civil and I would say infrastructural engineering is based on monitoring of structure. This is something that probably can be seen of belonging to a different field, but typically we really invest in holistic approach for design. And we believe that the design of next generation infrastructure should go beyond the resistance, should go beyond the crack limitation, which is typically also codified by international standard, looking at serviceability limit states, looking at ultimate. But how we can really enhance the performance of a structure, how we can really obtain resilient and I would say also sustainable structure that will be able to withstand the effect of climate change. If we embed sensors, but also if we do this in a non-intrusive way, particularly for historical building, by checking them regularly, we can get then the right signal, combining the design of resilient infrastructure with the early warning system, so that our structure will be able to withstand any type of extra stress. They will be resilient, but at the same time, they will be sustainable because we don't need to demolish, we don't need to really replace them very often, particularly when they are exposed to harsh environment in maritime. For example, we are dealing, for example, with wind turbine, and we know how important is the resilient design of foundation for those structures. But also, if you look at the highways that could be exposed to high climate change effect, high traffic. So really help structural health monitoring combined with early warning can really provide the engineer the right tool, but at the same time can provide this approach towards a multidisciplinary approach towards an holistic design that is really, I would say, only applied in few cases these days. And that's where we need to talk, we need to collaborate, we need to really share our knowledge, but at the same time we learn a lot from SME and also global players, global designers, so that we can then bring our infrastructure to the next stage. And really that's what is the aim of our research cluster at the moment. That's another very, very important question for what we do. And I would say for the type of results that we are obtaining. This is something that does not happen from night to morning, but is built on gradual approaches and I would say gradual improvement. And what I've been doing with my team, I've been lucky enough to collaborating with a number of partners globally in Europe, but also in US and in so I've been also exposed learn a lot from my colleagues, but also exposing my research to different contexts, which has been very fruitful and I would say also very beneficial. This type of fertilization and interaction with a different culture, even the design culture can be different based on different material, based on different contexts, but also more importantly, as you have correctly highlighted, different hazards. I've been lucky enough to work, for example, in areas that are exposed to multiple risk, natural multiple risk. And I mean earthquakes, flood, erosion, and also climate change effect. That's the case of the Caribbean and South America in particular. And basically what we have been doing, we have been relying on the conceptual design. That is very important. If you look, for example, at large infrastructure, sometimes it's not only what the type of solution, is the context and also the perception of the communities, which is very important. So the structural engineering cannot really be successful if it is not well embedded within the general community approach, where even the people, even the citizens that are going to use our infrastructure, they know exactly what the structure is about. They can understand, they can really even enjoy the structure, but they need to know the performance that is expected from a given structure. This is the case, for example, of hospital. This is the case of large landmarks, but this is also the case of infrastructure. Because if you, for example, build a nice, resilient, and sustainable infrastructure in a place where the engineering culture is not very advanced because of a number of historical reasons or political reasons, then what happens is that you are giving a nice gift, but it is not really appreciated. Mm-hmm. So basically what we really want to do, we want to really value what we do. And this is also can be measured in terms of metrics, in terms of return on investment, because if you invest in resilience and then you also create awareness of the sustainability and also the resilience through community engagement, that's very important. That's really what we have been successful on through, as I said, a number. I could not name them because probably we need more than 1 hour. All my collaborators, all the people that have been very honored, our organization in particular, global organization, that have been involved in this last 20 years. And I've been very, honored to have done so. I mean, this is in a way also linked to what you just mentioned. And in a way, I mean, I can say that I don't like to use the word proudness, but really here is a matter of how people have also learned, but more important, implemented what we have been discussing at academic level. And typically academic have seen those people that are a bit crazy because they work, on a sort of closed environment or they are too theoretical. What we really like to do is practical research, applied research. And in this case, the real element of impact, that's a really important word here, has been the change of paradigm. The change of paradigm in design, for example, critical infrastructure, that has been really the way and the reason why I was brought in and really had a pleasure of meeting people that, goes well beyond engineering, people working in humanitarian field, and also working on different fields, like, for example, politics and policymakers and decision makers, really have helped me also to develop this approach that goes beyond the engineering, and really where you, for example, have hospital and you discuss that there are options, and you then convince and also let other colleagues, in the case of engineering, but also physics, but also people work in architect, firstly, when it comes to construction, and also decision makers, to tell them that, for example, if you use advanced technology, that not necessarily they need to be expensive. It's just a way of changing the paradigm of how structure should be built. This has been the case, for example, in Haiti after the 2010 earthquake. This has been the case working closely with a number of organizations in Dominican Republic that I regularly visit, being also adjunct professor at Intech there. And also, I would say, helping the Pan American Health Organization as being member of the DMAG, Disaster Management Advisory Group, and discussing with other colleagues and really checking what are their priorities and how we can then suggest from the engineering perspective a solution. And more importantly, what is very important, this I think is a message that we should all keep in mind. We have the technology, we have the material that are classified as sustainable and resilient. Sometimes it's a matter of acceptance, it's a matter of availability. So that's where really we need to work work closely with local communities, not to impose, but really to discuss with them which is the best option for an engineering effective implementation for their own benefit. It's not easy to, because I should not answer to this, to be honest. I mean, I should be listening what my students through these 20 years have learned. And if they think that the approach that they use, I don't like to be seated on the other side of the desk. I sort of feel myself still a student. I dedicate even today a number of hours studying, which I believe is a sort of way of keep you young, but also to motivate the research that you do. And I really learn a lot from the inspiration that I get from students. So learning means listening, in my case, listening to their needs. And I've been, again, fortunate enough through my academic life, academic career, to have been exposed to a different audience of students, global students. And I'm really happy that I still receive now a lot of good feedback about inspiration. So to me, it's about transferring enthusiasm. It is beyond technicality. It's really getting what you can mention with a word, a Latin word, named curiositas. Curiosity means something that goes beyond your, let's say, technicality. Really means, why I'm doing this? What's the reason, and what is going to be the implication of doing this? If you start off, this is sort of, in a good way, I'm sorry to use this word, it's a sort of virus. It's a good virus, not not bringing back any sort of detrimental effect of the barrier of disease, but this is a sort of cultural disease where you get influenced by something that you bring with you. And to be honest, I would say, don't take any vaccine. I'm sorry to go in a different field here, but this is really something that you should bring with you, because this is giving you life. It's a sort of, the other way of getting infected. This is a good infection that you can bring with you, because this is really motivating your culture and really inspiring your professional activities. That's the way I look at it. Through what I mentioned to you this morning, I believe that, and I've been very lucky to be influenced by a number of cultures. So to me, traveling, getting in contact with people, knowing people, is not necessarily going out every single day, but is going out to world that is very important. If you are sort of close mind, I don't think you'll be influenced. I don't think even people what you are talking about or what you think about. So exposure to people and really engagement with the local and global community, to me, has been very important, and I till now continue to do so. So in I would say priorities, I always like to travel a lot. And of course, by traveling, you can also enjoy by, museum, art. I don't play, but I really enjoy music, particularly classical music and so on.